instead of lying on the beach. I really appreciate that. As said before, that course should be for you, so if you have questions, just interrupt me anytime. On the other hand, I will certainly sort of overload your brain with lots of information. I mean, this is 3 hours, and I have a lot of information. Normally I can teach that for a 2-year course at the university, so cramming that down to 3 hours is fairly difficult. You will immediately see that microfluidics is actually one of the fields which, on the one hand side, and that makes it so fascinating, is totally multidisciplinary, so you will see inputs from totally different areas, from engineering, from physics, from the life sciences, from chemistry, and so on. But of course, on the other hand, that makes it so difficult. So depending on which scientific discipline your background is, you will certainly, or hopefully, learn things which you haven't heard before. On the other hand, you will find maybe a few slides fairly boring. So let's see how that works out. As I said, if there's a question in between, raise your hand and interrupt me. I will be here for the next 2 days as well. So even if we not cover all questions today, I'll be happy to answer your questions over the next coming days. So just a little bit on what I'm going to be talking about today. It's a bit of introduction, of course. Then a little bit of theory here on the physical principles. A lot of the, let's say, more engineering part on materials and fabrication methods. And then, of course, I will try to, as well as the width of the field is permitting, try to cover some applications and products. And then finally I will conclude with a couple of thoughts on commercialization, because I mean this is a conference, of course, which deals with ideally products which one day eventually might help people. And so microfluidics has been seen as a field which eventually might revolutionize the life sciences 20 years ago. And so everybody's thinking, you know, why hasn't that happened yet? And I think I have a few slides on that one as well. So what should you learn? Some fundamental principles of microfluidics, of course, some basic understanding there. Then, of course, understand fabrication technologies and the limitations and the cost models of the various fabrication technologies. Some applications and products, and then, of course, some issues on commercialization. And you will see that, I mean, coming from a background, I'm a physicist by training, but I have been in microfluidics for some like 17 years now, and I spent the last 12 years in industry. You will see that this course certainly has a focus on how do we get these things done and actually into the market. You will see, I mean, I have to learn my living out of that, so it's not just writing or not writing scientific publications. I do that once in a while as well, but it's actually really how can we get these devices, this technology into the market to eventually, as I said, particularly for diagnostics, to actually help people.